Welcome to this lesson on constructions where we are going to focus on a really powerful skill, which is being able to find the middle of something. And that sounds kind of vague, but we're going to make it more specific in a moment. We're going to find the middle of two somethings. The first something is a segment, where you have something that looks like this, and I want to find a point that is in the middle of that segment. It's around here, but I want to find exactly where it is. And the other thing we're going to do is find the middle of an angle, which looks like this. If I have some angle, I want to know where is the line segment that goes right down the middle of that angle and cuts it in half. I'm also going to find a line segment that goes through this segment and cuts it in half. When you cut something in half, you end up with two pieces that are the same length, right? If I split the segment in half, then this side and this side, these two pieces are the same. Whenever we're talking about distances being the same, you should start to think about this very useful, very special shape that's important in constructions: circles. Circles give you points that all are located the same distance away from the center. And so we're going to use circles to find the middle of segments and to find the middle of angles. So I'm going to sketch things freehand over here. This is what goes in your notes, and then I'm going to do the constructions formally on the right side, and you can do that along with me if you have a compass and a straight edge. Otherwise, you can just watch this part and practice it when you have access to the tools. So if I have 2 points in space, one of them is A, one of them is B, and I want to find a point that's in the middle of those, I know that the point in the middle has to lie somewhere on the segment that connects A and B. It's around here, but is it there or there or there? Like, where exactly is it? It's around here somewhere, and through this midpoint, which, you can just break that apart and see that it literally means the middle point, there are infinitely many lines or line segments that pass through. Like, there's a line segment that passes through the midpoint and looks like that. If I was to pick a point on this line segment and ask myself, how far away am I from A and from B? I don't know exactly how far I am, but I know that they're different. This is some short distance, this is some long distance. If I swing this segment up a little bit, like that, and then I pick some point on the segment, I ask myself, how far away from A am I? How far away from B am I? Well, I don't know what those distances are, but I know they're not the same. I'm closer to A than I am to B. If I was to swing it way far over onto this side and pick a point here, now I'm closer to B than I am to A. In between here and here, there was a special segment. There was a special line that passed through the midpoint and also satisfied this other very useful property, which is every point on this line, doesn't matter which point I pick, like if I pick this point is equidistant from B as it is from A. That point right there is equidistant, which means same distance from A and B. If I could find this segment, create this segment, I know that when this segment passes through segment AB, it's going to hit the midpoint. So I'm going to try to construct this segment right here. And the way I'm going to do that is this. I start with AB, and keeping in mind that this point is the same distance from B as it is from A, I'm going to take my compass and I'm going to open it up by some distance that is more than halfway. If it's too short, this won't work. I'm going to open it up more than halfway, and I'm going to swing down and create an arc. I'm also going to swing up and continue that exact same arc. So I end up making something that looks like this. I keep this distance fixed. I flip the compass around and I go to this side and I make the exact same arc. And when I do that, I get something that looks like this. This one swings in that direction. It's a little crooked, but it's freehand. We'll do it for real over here. Let me make that a little better. So this goes like that. This point right here is like that point. It is a point that is the same distance from A as it is from B. Up here, there's also a matching point that is the same distance from A as it is from B. And if I connect through those intersections like that, I end up finding the midpoint. And not only that, but in doing this construction, I ended up doing this other construction, which is something called a perpendicular bisector. So perpendicular forms right angles. So when these two segments cross each other, they form right angles. There's a right angle there, there's a right angle there, there's a right angle there, there's a right angle there. And it's a bisector, which means it cuts AB in half. Now the thing in this picture, which is the perpendicular bisector, cuts in half. The thing in this picture that's the perpendicular bisector, it's not that point, it's not this arc, it's not that arc, it's this segment. This segment here is the perpendicular bisector. Let's do that construction. I start out with some segment here. I'm going to highlight that point or bold that point and bold that point. Here's A, here's B. I want to find the midpoint. In order to do that, I center myself at A and I open up more than half. Doesn't matter what it is as long as it's more than half and you can fit yourself on the page. So I'll swing my arc like that, come over to B, I don't adjust anything, pin myself there, and make the exact same arc. This point is important, this point is important. If I connect these 2 points, I get that, which is my midpoint, and I get this, which is my perpendicular bisector. I want to clarify something about this, this term bisector. A bisector cuts something in half. If you bisect a sandwich, you will create 2 congruent, which means they're the same, halves of a sandwich. If you bisect a segment, let's continue this logic, you will create 2 congruent, they are the same, halves of a segment. Bisecting a segment gives you segments. If you bisect an angle, 2 congruent halves of an angle are formed. Do not mix these up. Of course, you are not going to mix up sandwich with segment and angle, but it can be tricky for people when they think about bisecting something to keep in mind what is getting bisected. Like they hear the word bisect and they say cut in half and they just say everything's getting cut in half. But you have to be more specific than that or think more specifically than that. If a segment got bisected, the segment got cut in half and I get 2 congruent halves of the segment. If an angle got bisected, like this is an angle right here. You see how this side and this side are very different lengths? Doesn't matter. If I bisect this angle, I'm going to cut that angle in half. and it has nothing to do with these sides. And this is the construction that we're going to do next. All right, now let's bisect an angle. And here's how we can think about this. If we have some angle here, and we want to find the segment that passes through and cuts that angle in half, we know that we can think of it as going through the middle of the angle. And the reason it's useful to think about the middle is because when things are in the middle, they are the same distance apart. So I'm going to travel out on this side by some distance and mark that point. I'm going to travel out that exact same distance on this side and mark that point. And now I'm going to look at how far away this segment here is from these 2 points. If I pick this point right here, if this segment is really going through the middle, it's going to be the same distance from here as it is from here. I could pick a different point, like over here. This is going to be the same distance from there as it is from there. I could pick this point over here. It's going to be the same distance from here as it is from here. So if I can find 2 points that are the same distance from over here as they are from over here, that's going to let me create this segment. And the way I'll do that is to set my compass at that vertex, open up by some distance, and make an arc. Doesn't matter how big the arc is as long as you end up hitting both sides. So I'll make some random arc, and then I will highlight or bold that point and bold that point because those points are important to me. I move the compass to one of them. I open up more than half. Again, it doesn't matter how far you open as long as it's more than half, and you make an arc, and you make your arc swing to the right and you make it swing to the left. And when you do that, you get something that looks like this. So this was step 1, this is step 2. Step 3 is I keep this fixed. I don't change anything, I just flip it around and pin myself right there, and I make the exact same arc. And when I do that, I end up finding that point and that point, which are my 2 points that are equidistant from the sides, and I can connect them, and it will end up cutting through the angle, finding the middle of the angle, splitting the angle in half, bisecting the angle. So here's what that looks like. I start with some angle. I pin myself to that vertex and I open up by some distance, enough that I'll end up hitting both sides. If I opened up by this much, that would be too far because I wouldn't hit this side, so I'll go in a little bit, I'll go right there. Make an arc. Move to one of the intersections. I'll start with that one, then I'll do that one. Pin myself there, adjust this so that I'm more than half. That seems good. One arc. Don't change any distances, just slide over to that point, make the exact same arc. And you can see here I came really close to not intersecting. I did actually intersect. If this wasn't drawn in enough to intersect, I would just come back here, pin this, and extend the arc a little bit more so that I'm clearly crossing. And now that point and that point are important, so I line up the straight edge, and there we go. This was the whole angle. This is now the same as this.